Talked about 3 ways of graphing and working with parabolas. We had talked about standard form, intercept form, and vertex form. And each one of them had their own way of working. Well, the stuff that you were doing last week is actually a little bit more complicated than what this is going to start out as. Exactly. What's going to happen here is that we're going to start talking about parabolas that are up or down, or right and left. We're going to talk about all 4 types today. And all 4 types of them, we're going to write them in terms of what are called a conic. Conics are basically anything that has a curve. Conics are parabolas, hyperbolas, ellipses, and circles. All 4 of those are the main conics that we look at. You guys last year in geometry worked with circles. You guys did an equation with circles that did x minus h quantity squared, y minus k quantity squared for your equation of the circle. That was h and k, guys. That was horizontal and vertical shit.
Yeah.
Ooh, it's crazy. So what we're going to look at here today are parabolas. And I'm going to define parabola a little bit different. You don't have to draw all this up here. But we're going to talk about y equals something ax squared. Everything we do today is going to be centered at the origin. Your vertex is always going to be at 0, 0 for today. What we're going to do is define parts of a parabola, what each and every parabola has. Tomorrow, we'll take it and move them off the origin. So today is just kind of like the framework of what's going on. What happens with a parabola is just like your regular basic old up like a cup parabola. Every single parabola has a vertex. Okay? The vertex for today is always going to be at the origin, just for today. So we have our vertex. What else it has is something called a focus. Now, here's what's nice. When you think about a focus, that means you're looking at something, correct? Yeah. Can I steal your glasses, please? Thank you. Glasses are, I mean, you can't see this, can you?
No, I can.
Glasses are curved.
Yeah.
The way that they're curved is so that you can focus at something. This is where this terminology comes from. Thank you. What happens here is that this curve opens or closes to focus at a point. So now your glasses are made to see at a specific point. My contacts, the same thing. They're made so I can see a certain value. That's how those things are made. Well, to counteract a focus, there's what they call a directrix. A directrix. A directrix, like tricks are for kids, silly rabbit. Now, if you think about what's happening, you get a focus point, a vertex, and a directrix. These values, this distance here and that distance there, is always the same. That distance will always be the same. It's just going in a different direction. So the signs will be different. Okay? A directrix balances a focus. Does that make sense? The further out the focus is, the further out the directrix would be. The closer in, the closer in. All right. What will happen here is you'll see it as we start to graph these things. One thing I'd like you to notice is the directrix, if you're up like a cup or down like a frown, is what type of a line? It's horizontal. It's horizontal, all right? This directrix, if it could, it would want to slice through your curve. But since it can't, it won't. So if it's turned when this stuff is turned later, when I turn this like that, it still does the same thing. Those parts are still there. They're still in the same spots. Your curves are always going to open up to the focus, and the directrix would be behind it. All right? Not so bad? All right, well, let's define where they come from. You have two basic ideas here. Yeah, this is going to be important. This is the important. Now, I don't like writing things horizontally. I like to do stuff like vertical math. We're going to get this x squared equals 4py, or we're going to have y squared equals 4px. The difference here is whether or not it's going to go up and down or left and right. When you have an x squared parabola, an x squared parabola is going to be one that opens up either up or down. And we've been working with those. We've always been working with those for all of these. Oh, you don't need any of that.
Oh.
Okay, and don't worry about what's up there. I'm going to explain to you in very layman's terms of what we're looking at today. I'm just going to use the up for right now, but just remember it can go up or down. Our vertex for today is going to be at 0, 0. Okay? Now, if my vertex is at 0, 0, and my focus is going to be vertically to that, what will be the x-coordinate for my focus? 0. Very good. What's happening here is if my vertex is at 0, 0, where's my axis of symmetry? 0, 0. It's at 0, 0, isn't it? My axis of symmetry goes through 0 in this case. Therefore, if my focus will be at 0, and whatever this p-value is, 0 in p, then my directrix would be below it at y equals the opposite of p. Because y equals is a horizontal line. Do you agree?
Yeah.
It's not a coordinate. It's the p-value, whatever this p-value is. So, and I'm going to show you an example here real fast. Yeah. Because remember, the p-value, and you're going to see how to find this. I'm just starting with the framework. When we get into the actual solving of what it's going to look like, it's very quick. It's very, very easy to work with. All right. Now, when I'm talking about a horizontally turned, or I should say horizontally, left or right parabola, it's just the opposite. I'm just going to use the right for now, just so we get a visual idea. Again, our vertex today is going to be placed at the origin. We're not moving things around yet. So where's my axis of symmetry? 0. Now is it, since this is a horizontally opening or left or right parabola, is it going to be x equals a number or y equals a number for the axis of symmetry? Y equals is my axis of symmetry. So y equals 0 is my axis of symmetry. My focus, remember my vertex opens up to the focus, so it's going to be out here. What do you think the coordinate for that will be?
P comma 0.
P comma 0, very good. And then the directrix would be behind it at x equals negative p. And that is a,
Why do we need a number for that?
I'll show you. Yes, sir.
And so we just kind of guess for what P is?
No, I'm going to show you you're going to be able to do a one-step algebraic thing to get P. It's very simple. Okay, it's very, very simple. All right. So what we're going to do here is we're going to take that info. Let me write this up here real fast. So we have x squared is 4py And then y squared equals 4px. And we'll go from here. Okay? Let me show you an actual number one. I'm not using graph paper because graph paper is evil. We have x equals negative 1/6 y squared. Okay? X equals negative 1/6 y squared. Excuse me. So the first thing you're going to do with these types of problems is tell what you have. Either x squared or a y squared problem. We have a y squared problem. So that means this is moving left to right. So what we want to do is we want to get the y squared by itself. How do I get y squared by itself? Multiply by negative 6. Everybody okay with that? So I get negative 6x is y squared. All right. Now, this is going to mirror our 4px equals y squared. Everybody okay with that? I'm just writing it next to it. Here's where it gets interesting. The coefficient of x, is it positive or negative?
Negative.
It's negative. So what direction do you think this is going to open? To the left. Very good. It's going to open to the left. This is a y squared problem, so you either go left or right. In this case, since it's negative, it's going to open to the left. Make sense? Okay. We know it's going to open to the left. I don't know exactly where anything is, but I'm just going to do that for right now. I've told you earlier that everything we do is going to be centered where?
The
origin. The origin. So I know my vertex is going to be at 0, 0. I know that for certain for right now. The rest of it we're going to make up as we go along. Here's what we have to do. In order to figure out what the p-value is, you take this number and you set it equal to 4p. You do that every time. So negative 6 has to equal to 4p. So what's p?
2/3. Negative 1.1.
What is this decimal thing?
Sorry, negative 3/2.
So my p-value is at negative 3/2. That tells me now that my vertex is at, what's that point? Oh, thank you. Focus, thank you. My focus is at?
-0.
Yep. Focus is at negative 3/2, comma 0. And then where's my directrix?
Positive 3.
It's at x equals 3/2. These two distances are the same.
So we just have to draw the thing.
Basically for right now, yes. When we get into the ones that we have to shift, I'll show you what we'll do things a little bit differently. But for the most part, that's what we're looking at doing today. Yeah, that's it. Oh, it's just me. It's just showing that they're the same distance. That's all. You don't have to do that. It's when we get into some of the other shapes that we'll graph out with the different values, it just looks kind of cool. You'll see it later. All right. Not bad, is it? So we know what the directrix is. We know where the focus is. We know where our vertex is. Very rough sketching graphs. All right. We'll do another y squared one.
Yeah, you can do that.
Okay. We're doing another y squared problem.
Hey, I thought you said no slashing for actual.
Hey, I tried typing in the computer and it didn't work out real nicely, so there. Cut me some slack.
Got him.
Wow.
Gosh, man.
She got me. She got me on that one. She's right.
He's an eyebrow slashing for action.
I'm sorry.
How come you have Nemo stuff all over?
I don't know.
Was it something?
I think it was.
Nemo's great now.
Here, there's no slash correction.
There you go.
In this case here, Do we agree that's a y-squared problem?
Yeah.
So it's going to go left or right. Which direction do you think it's going to go?
Right.
It's going to go open right. Correct. So what I'm going to do is, what do I have to do to the 3/4?
Multiply by 4/3.
Very good. So I get 4/3 x is y squared. Are we okay with that?
Yeah.
All right. So, suggestion, write it out. 4px equals y squared. What do I set equal to 4p?
4/3.
Very good. So we get 4/3 equals 4p. Now, put your calculators away and trust yourself for a second.
Oh, it's 4 over 1 divided by 4.
Isn't that the same thing? Divide by 4, multiply by 1/4.
Yeah.
Yes.
You get 1/3.
Yeah.
So your p value is 1/3. What's that?
The calculator says 3.
Your calculator is wrong.
That's why you don't do your calculator.
Hey, the other window supposed to be brain.
So we know that this is going to be opening. Oops, move this over just a bit. Our vertex is at 0, 0 for today. It's opening to the right. I know that my focus is at 1/3, 0. And where's my directrix? Good. At x equals negative 1/3. Now, one of the reasons why I'm not worried about getting those symmetric twins is because your table and your calculator would give them to you. Now, you guys have a button in your calculator that says y equals, correct?
Yeah.
It doesn't have anything that says y squared equals, does it? No. So if you wanted to get your ordered pairs to show how this works, which we will do that when we shift things, but for today I just want to give you an idea of where things are going. Here's how I would type something to my calculator to find out some points and stuff. I go to my y equals. Our equation was 4/3 x equals y squared.
Wait, can you clear your
Does everybody agree that if I wanted to get y by itself, all I have to do is take the square root? So here's what I do. I do square root of a fraction, alpha y equals 4 over 3 x. I'm making it look exactly like the problem. And just hit enter, or excuse me, hit graph, just so you get the idea of what it looks like. My window's a little messy, but we'll clean that out.
Yeah, it's got one.
Yeah, I just got one
I can just go across.
Well, yeah,
It's a linear.
of course you have one line. Why do you think you only have one?
Don't you need two?
Is it just like
You're getting one line.
No, we took the square root, but what did we do?
You only square root
Not
one
a lot.
of the numbers. You didn't
I only looked at
square
the, I didn't do plus minus.
It is different.
Because, do I really care? Do you guys agree that this would have a symmetric twin underneath it if I did plus minus because I took the square root?
Yeah.
That's why. Now, you could do another y equals and do a negative square root 4/3 x, and you can get the bottom half. But if I know that it's symmetric, what do I care? I don't. Because I'm centered at the origin, so it's very easy to get ordered pairs. For example, 3 and 2. What would be the symmetric twin to that? Negative 3, negative 2 would be all the way over here, and you would be wrong.
It's 3 negative 2.
3, negative 2. The symmetric twin would be 3, negative 2. See that? In my table. I didn't do it. I don't want to do any math. That's hard. Okay. What I'm doing here is just some very simple. That's why I don't spend a lot of time going into getting ordered symmetric twins, because your calculator does it for you. We're just doing some rough ideas here today. Okay. Now, What's going to be different, though, write the equation into the standard. What I mean by standard form is what we're doing today, the y, the 4px, that kind of stuff. We're not going back all the way into this. So I have write the equation in standard form with the vertex at 0, 0, which is where we are today, and it has a directrix at y equals 2. And I need to figure out how to write this out. So that means you have to decide what direction is this curve going. So here's how you do this. Y equals 2. What kind of line is y equals 2? It's horizontal, not vertical.
Yeah, that's good.
It's a horizontal line through. So if my directrix is a horizontal line at y equals 2, what direction is my parabola opening? It's opening downward. Because this is behind the vertex. It's going down this way. Which means, what is the value for p? Very good. It's -2. Hey, hey. How are you? All right, so it's at -2. Because these distances are always going to be the same. All right? So that tells you that your p-value is -2. I know that this is an opening downward. So is this an x squared or a y squared parabola?
X squared.
It's x squared. So it's going to be an x squared equals 4py. And our p-value is? -2. So it's 4 times -2. So x squared equals -8y. And you're done. Because you're trying to get it back to that x squared, that 4px or 4py, or whatever works out to be like that. All right? You're taking some of the information that they give you, whether it's going to be the focus or your directrix, knowing where that's going to be placed, because everything is centered at the origin. Okay? All of our stuff's going to be centered at the origin. So if you do a rough sketch, you can back yourself out of it without too much of a hassle. Okay? Let's try another one like that. Ooh.
Oh, what?
Wrong one. Yeah, right. Where's my slant thing? Did that go through? Okay. Here's the other way of doing this. The focus is at 4, 0. And I'm going to write out the equation. So my focus is at 4, 0. And I want to write out the equation. Remember, everything is centered at the origin today. Nothing's being moved around. Okay? If everything is centered up at the origin, I'm going to just make a quick grid, plot my vertex.
Wait, that's the focus?
That's the focus. Yeah, the focus is at 4, 0. So 4, 0, is that on the x-axis or the y-axis? It's on the x-axis, and it's there. What direction do you open?
Right.
I open to the right, because remember, your curve always opens to the focus.
Oh, yes.
So what's your value of p?
-4.
Is it -4 or +4?
Negative.
Positive, because I'm opening to the right. P is positive if you're going up or right. P is negative if you're down or left. And it's just focused at.
Oh.
At.
What?
Whatever.
Where you talking about? It's a hat. The at like with the A
There.
in the middle. Yeah, I never got that.
Ampersand.
I do the A and then you go around. Yeah.
You're lucky I can spell.
But you can write an A, you can just put a circle around the A.
I know. I tried.
It didn't look like you tried very hard.
I think he did.
Try it one more time.
That's good.
Come on, it's a Monday and I got to wear a dead t-shirt. Come on, like I'm really trying hard today.
What?
Compared to that t-shirt, we're supposed to wear tie-dyes, that might be like one of the 3 t-shirts that own a dead shirt, so. Anyway, so our p-value here is 4. Is this an x squared or a y squared parabola?
Y
It's
squared.
y squared, so I started right now, y squared equals 4px, and what is our p-value?
4.
What's 4 times 4?
16.
And there's your equation,
Wow.
okay? These things, using what you know about directionality, it's rather simplistic to work with these, all right? Yes, ma'am? Yeah, it would be just like we just did. I'm going to give you stuff that have, I'll give you the focus, I'll give you some that have the directrix, and I'll ask that you guys graph a couple. Yes, ma'am? Nothing. If I was given this equation, if I was given y squared equals 16x, I know that it's a y squared parabola. So what I do then is y squared equals 4px. And then I set that equal to 4p. And I do what we were doing earlier. Does that make sense? Let me give you a few of these to try for tonight. I think what I had on here was just this.
I think like 5, 6, I think.
Oh, let's see. This is section. Oh, I have to upload this. I'll get this in here on the website.
I did the homework.
50 through 53. 60, 63. And 72, 74. Okay? It's 12. God bless you. I gave you 4 of them that you're graphing. God bless you. I gave you 4 of them that give you a focus. Let's wait for the third one there. No? All right. And then 4 of them give the directrix. I totally forgot that I did not upload this page into the on the website yet. I'll get this up next hour. So don't do your homework online for about 20 minutes. Yes! There it is! Bless you! 3 times the charm. Okay?